Welcome to Simplilearn Data Structures in R. My name is Orion Stallard, and I appreciate you joining us today. We're going to just take a quick look through some of the high-level aspects of R programming. If you're new to R, it's a very powerful and easy-to-use programming language. It's been around since 1993, and it's grown in popularity to what we would argue is really the top data science programming language in the world. It's open source, so it's free. Originally, it came out from the University of Auckland. Two professors launched it to help their students, and it got so popular that they decided to continue the work as an open source programming language. It's been revised multiple times, and it's now a popular choice with businesses, with educational universities, and institutions of all walks throughout the world. So again, if you're just starting R or you're just trying to figure out what it is, this is a really good time and place for you to be here. If you have a background in computer science, then stay with me. We're going to do a quick high level on this, and it should refresh you and remind you of things that you already know in the language that you started with, whether that's Python or whether, for instance, if you're in C or Java. There are going to be common elements across all languages, hence R is a Turing-complete language. So these are the things that we're going to hit on in this lesson. Again, this is just a quick summary to get you familiar with the data structures so that you can launch whatever application you would like to quickly, and I don't want to say effortlessly, but with a little bit of thought, preparation, and planning, you'll be well on your way to using this tool as soon as you'd like. And the fact that it's free, R that is, compared with many other competitors, makes it that much more of an accessible tool that you can actually use really right now at the end of this lesson. So explaining the different data structures, discussing the elements of the data structures, and the acceptable formats for import and export is the goal of this lesson. It's brought to you by Simplilearn, and our purpose here is to help you excel and reach your goals using R programming. So as you can see here, there are 5 types of data structures in R, and in kind of order of complexity is the way that we've arranged them here. Vectors are the simplest. Vectors are, of course, one-dimensional, as you can see in the picture. We've illustrated that with these 3 blocks. But a vector, in essence, is going to be all data types that are the same, such as a numeric, a character, like a string, you may call it, a logical, true, false. Any of those data types, factors, are going to be of the same type if they're contained within a vector. In other words, you don't have logical and numeric, or factors and numeric contained within a vector. A matrix is a vector that has been expanded into a grid. So you now have a 2-dimensional format similar to a table. And the same is true with a matrix that is true with a vector. In fact, you could look at a matrix and consider it to be a group of vectors that have been joined or appended together. An array adds dimensionality to matrices. So arrays can expand matrices, and if you have a computer programming or a database background, if you are familiar with or if you've ever heard of the online analytical processing cube, this array would be a good analogy to an OLAP cube. Data frames are by far the most commonly used data structure in R, and the reason is because data frames now are the first place that we can combine elements of different types. And so that would be the same that you may be familiar with if you've been accustomed to using workbooks in Excel. If you are putting data into columns that have different data types, such as your best friend's name, their birthday, their favorite color, whether they're a boy or a girl, if they're over 21, different things like that can be contained within a data frame. And carrying that a step further, all of these that we've just discussed can be contained within a list. So a list is actually the most complex data structure in R. And as we just talked about, vectors are one-dimensional arrays, and these are examples that you can use. You can use these in your own life, whether that's in your business, in your education, if you're a student right now, if you're a professor at a university and you want to keep track of students. Any of those would be easy places that you could organize a vector. You could put a vector of your students, for instance, together as we see here. B gets C, and C stands for combine or concatenate these elements, or in this case, these are like strings or factors, 1, 2, 3. Notice, and it's important that we spell out the fact that when we want to identify a factor, that it is both contained within parentheses and quotation marks in R. And R is also case sensitive, so that's important to point out. Logicals, true and false. You can see that we have a vector that we're identifying here. So this would be a single vector, true, 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 false, true, false. A is numeric, B is character, C is logical. Scalars are one element vectors that you would use for a constant value, something that you're going to continue to refer back to. In R, scalars, unlike some languages, start with the value 1. In this case, for instance, F gets 3. Anytime we print F, 3 is going to follow. So a colon is a way to use a little shorthand notation, and these are just a few kind of sidebar things that are important to be aware of that we're going into here, but it's just good to know that in the expanded format, for instance, with numerical, you can use commas, and you can put 1 to a bazillion numbers here, or I could simply start with the first colon and followed by the last number. So in this case, A gets 1 through 5. If I print A, it's going to print out 1, 2, 3, 4, 5. The same thing is going to be the case here. There's just a lot less typing in the first example. So accessing vector elements. The brackets give you a convenient way to pull elements out of your vectors, and that would be very handy. For instance, if you are starting a business and it's the next Uber or the next Google, and you need to kind of zoom in on the customers that pay you the most, and you've developed an algorithm for doing so, and you know it's every other customer, for instance, then you could use this command, vector combine, and then within the square brackets you can then say combine, and within the curved brackets 2 comma 4, and you could continue this 2 comma 4 comma 6 comma 8, and what that will do is it will take and return, in this case, the second and fourth, and if you said sixth here, it would return that. So here vec1 is going to return the letter A, the first element in the vector. So when we identify a variable and we assign a vector to that variable, then the square brackets allow us to quickly pull elements, data elements, from the vector. So that's a nice little way to quickly look at your data in R. Matrices, as we talked about, are two-dimensional data structures. They're pretty much vectors that have been combined together. And you'll see how that works in this command. So vector 1 through 4, again, we've expanded it out instead of using a colon. And then what we do is we take another variable, which we call foo, and we could actually call it anything. You could call it calculator, you could call it x1. But this is the assignment variable that we're using, and we're saying foo gets, and we're now using this function matrix, and matrix is now using what we previously defined as a vector, and it is within the function putting it into the number of rows of 2 and the number of columns of 2. So it's taking this vector 1, 2, 3, 4, and it's making it into a 2 by 2 grid. Again, the elements of the matrix have to be the same type. So if you had 1 through 4, it's all got to be numeric. If you had Sally, Jim, Bob, and Joe, it's all names. If you have true, false, false, true, it's all Boolean. But it cannot be a combination of those for it to be within a matrix. This is a little optional parameter that some people like. It allows you by row allows you to pretty much interchange the configuration of the matrix from, you know, a kind of column to a row format. Some people use by row and enjoy using it that way. When you want to pull data from your matrix, like we did with vectors earlier, this is the command, and it works the same as it did with the vector. You have a square bracket, and within the square bracket you have a comma. On the left side of a comma is going to refer to the number refers to the rows, and on the right side of the comma refers to the columns. So if I want to get row 1, column 2, an element that's in that position, then I say mat square bracket 1 column 1 comma 2, and that will give me the data element that is in the first row of the second column. Mat, of course, is short for matrix, and the square brackets is telling R that you're retrieving information from your data structure, whether that be a vector or a matrix. The same holds true with an array, and with an array, of course, we have more than 2 dimensions. So we have to specify within the number of dimensions of the array exactly the row and column. So you know, in this case, what we're doing is we're setting up an array of numbers, and we're calling it variable A gets this matrix, and then what we do is we actually we identify the number of dimensions that would represent the rows followed by the columns, and in this case we can then take A and B, which are 2 matrices that we've just created, and we combine them together into our array, which we've named it arbitrarily foo, and that is the way that you can begin to experiment with arrays if that's a data structure that would be conducive to your business model or to the type of work that you're interested in. And the same as the way that we were able to access data with the matrix is how the arrays work. Again, with the square brackets and the number that you of the row or the column in arrays, we refer to them as dimensions. So foo 2 comma comma is going to get the second all the elements in the second dimension. That's this case here, 2, comma, comma. So why is it all of the elements? Because we've left to the right side of these two commas, we've left blank. In this case, 2, comma, 1, comma is going to give you the first row element in the second dimension. But it, as you can see, we also left the last space here blank. So that's a good way for you to look at dimensions, the number of dimensions that you create within your arrays, and to begin to retrieve data using using the square brackets within an array. Data frames, as we talked about earlier, are really the most popular data structure in R, because you can now use a data frame to combine different data types. So numbers, characters, logicals, they all are fair game and play in the data frame. So in this case, what have we done? We've taken 3 vectors, name, sex, and age are going to be the column names in effect. So in this case, we're combining Joe, John, and Nancy. Sexes are male, male, female, and ages are numeric, 27, 26, 26. And we've now created foo is our data frame, which combines the 3 vectors, name, sex, and age. And as you'll see, if we want to pull data from any of those vectors within our frame, it's very simple. Just like if you're using another program that's got a tabular format, such as Excel, you've got columns and you've got headings. These would be the column headings, name, age, and by just running the command foo, name of our data frame, $age, we're going to get everything that's within the age vector of our data frame. And you can see the nice thing, making the comparison with Excel, again, is that R is free, and R can handle a lot more data than Excel can. Excel kind of chokes at around 1 million plus lines or rows, where R can get into really hundreds of millions of rows. So when your data set grows beyond the capability of something such as an Excel type product, this becomes a really quick, easy, convenient option for you. Okay, so these are going to be categorical variables, which are factors, and of course we're giving you some examples: gender, status, so on. You can see again that the factors are require that we have curved brackets as well as or parentheses, as well as quotation marks around our string variables or elements within R, in order to tell R that that's what you're doing. So in this case, we've got gender, status, and what we're doing is we're looking and saying factor status gets, and oh, one thing that's important too that I haven't mentioned yet is the number sign followed by a string of characters is how you notate your code in R. And it's important to know that you can only do that one line at a time. It's not like you can write, a whole paragraph with that number sign, but the number sign and the code notation, of course, is considered good form for anybody who comes behind you that's looking to follow your code. Lists, as we talked about, are the most complex data structures in R, because lists can combine any variation of arrays, matrices, vectors, you name it, and in fact other lists. And so lists have the potential to get out of hand, but if used properly, they can be a very effective tool. In this case, what we've done is we've taken a vector, 1 through 4 and a matrix 2 by 2, and we've said let's take foo and make vector or vec and mat into a list, and that's what you're looking at there. So the remainder of this little talk about R, that's really just designed to give you a taste and get your feet wet and work your appetite up for launching your career into R. The remainder is really about importing and exporting data and the file types that you can use and what works best. So to start, these are the 4 you're looking at: Excel, Minitab, tables like text, and CSV are the 4 file types that you can import into R. And a couple things that are important for you to know, and we've notated it here, is when you're loading data into R, everything in R is done in packages. So the beginning load gdata package is what you see here. Library is effectively what tells you if you have a package installed in your in R. And so library gdata is actually loading the package that you're gonna use for your data set. Help is a good command to to be able to understand any function in R. So keep the help function itself handy. And in this case, what we're doing is we're saying my data equals read.xls, and this is reading from the first sheet of our Excel file that we have in a file path. In this example, the second example here, we're loading a different package but affecting the same thing, and load workbook mydata.xls. In essence, what we're doing is we're loading an Excel sheet into R. In this case, we're loading a mini tab, and foreign is a package that is probably best to use to load other file types, including Minitab. So that's one that a lot of people like to use. Help read MTP is Minitab Portable Worksheet, I believe is the abbreviation. And here we're assigning my data equals read MTP. That's gonna pull in whatever you have in Minitab. And this is a way that you can import text data that's in a table. So read.table mydata.text is an example there. One thing that I will say is the CSV that you see here, read.csv, that is actually the preferred way, in my opinion, to load data into R. If you have data stored as another file type, convert it into a CSV, even if it's in Excel. And the reason is because R and CSVs just tend to get along really well. They tend to have a lot less errors than other file types in my experience. The 3 data type files that can be exported from R, again, are table, Excel, and CSV. Table, of course, is exporting data as a text file, and you can see that with just a quick command, everything in R is the functions are very simple. So write.table, my data, comma, and then your file path, and you're done. Once you have your data set structured in R the way that you want, and you'd like to present that table to someone, a colleague, coworker, friend, teacher, boss, whatever it is, this is the command that you're going to use. The same thing is true with XLS and CSV. Again, my experience is that CSV tends to work best, but you'll if you get into R and spend time with it, you'll of course work out what's most comfortable and convenient for you. So write.csv, my date file equals my data.csv would be kind of the preferred method for me.